All right, all right. It is 2:15 UTC, and welcome once again to Astronomy Daily Live. Little bit of a late start today because there was just a Falcon 9 launch from Florida, and that actually happened successfully at 1:45 UTC. So I wanted to give both myself and those of you who are liking those kinds of things a chance to watch it. Bobby, I sent the link. I sent the link in the normal way. So let me check that really quick to make sure that I actually did. But I think I sent it a little while ago, and I'm looking to make sure that I sent it to everyone. Ooh. Oh. How did I do that? Bobby, somehow I missed you. So here, I'll send it out again. I don't know how that happened. It's become such a habit that to break that habit is kind of unusual. All right, I just sent you, Mr. Bobby, the actual link. So yeah, come on in if you are so inclined. Yeah, excellent. So Bobby will probably be joining us here momentarily. That's always awesome. So yeah, just had a successful Falcon 9 launch at 1:45 UTC. Looks like it went off without a hitch. They're currently in their second stage burn. I don't know a lot of the details of this mission, but the primary satellite being delivered is an Indian communications satellite, which is going to geosynchronous orbit. So, they're having to give it quite a bit of a boost to get it out there. So, yeah, they fired off the first stage. They fired off the second stage for a little while, and they coasted for a while, and now they've turned the second stage back on to actually get it out there. And there he is, making the regular appearance. Hey there, Bobby, what's going on?
Hey, what the crap?
What happened? What happened?
Yeah.
I don't know. It's become just a normal habit of mine, to send out, the regular invites, and for some reason these fingers just failed me this time. So I'm going to blame the fingers. So what's going on over there, Bobby?
Nothing much. I might want to catch the launch on the demand and stuff, and so when it becomes available.
Oh, good. Yeah. No, it was a good launch. They landed the first stage back on, one of their landing platforms out in the Atlantic Ocean. That looked really good. One really cool thing was that during, they have a camera on the first stage showing the descent, right? And through the grid fins, right? Now these, I think there's 4 of them. They're like these rectangular waffle-like things that pop out when the first stage is coming down, and it actually allows them, to steer and all that. Well, through one of the grid fins, you could see the moon rising, right? So it looked like a really, really, really bright light. And at first I'm sort of like, huh, is that like a landing light or something? Or what is that, right? And then I looked at it, it's like, wow, that's the moon. Yeah. So they had the moon shining through one of the grid fins as this thing, was coming down, right? And then when it landed, the camera on the actual, floating platform had, the first stage landed, and in the background was the rising moon. So it was a great shot. Great shot. Great, SpaceX is sort of becoming known for these great like PR shots, right? That are just like really, really great. So yeah, that was a successful thing. The the geostationary or geo orbit communications satellite is kind of a great thing, but there were two other secondary payloads. One was a Air Force Research Lab experiment of some sort. I'm not exactly sure what that was, but the other one was the Israeli team lunar lander, right? So they're actually going to be landing on the moon, I guess in about 40 days or so, right? So the reason why it's going to take that long is because they don't have enough oomph to sort of propel themselves directly, right? So they're going to have to swing around the Earth a few times, right? And so it's sort of going into a geostationary orbit, really, really high, and then it's going to come in really, really low again, and right when it whips around the Earth, they're going to step on the gas, give it a little push, right, and then they'll fling it out again, and they'll do this a few times, right? That's probably going to, I'm not exactly sure like how many times that's going to take, but it's going to take about, at least what I heard, about 40 days to get to the moon. So yeah, they're actually gonna, this group was actually one of the contenders for the Lunar X Prize, right? And the Lunar X Prize was this $20 or $30 million prize that was put out quite a long time ago and the challenge there, I don't remember the exact details of the challenge, but you had to land something on the moon, and then you had to somehow move at least 500 meters, and you had to take HD images or something. I forget exactly what the exact parameters were. And there were a bunch of groups from around the world that were working on this, and there was a deadline, right? And that deadline came and went, and nobody was ready. So they extended it at least once, maybe even twice, and still nobody was ready, right? So they ended up canceling the prize. Excuse me. But this group from Israel, they were basically set to go, right? They actually bought a ride on this Falcon 9. Wow, it was a couple of years ago, right? And there's another group, Moon Express, who is going to actually be putting something on the moon. I guess next year. I actually tweeted at them today, asking, what's going on, and yeah, they're going to actually be sending a number of landers on the moon, and this first one, I guess, is supposed to launch and land next year. So yeah, this Israeli group I think, I'm not exactly sure when this satellite is supposed to be deployed, but it's probably going to be, like, if it hasn't already, it's soon, very, very soon, to be deployed. So I'm looking forward to following that mission, because I have a very, very strong interest in lunar landers, because I want to put a telescope on the moon, and that is going to require a lunar lander. So yeah, I'm extremely interested in what these folks are doing, and I sort of completely forgot about them until a couple days ago, when it's like, wow, they're going to be launching in a couple days, and it's like, wow, all right, so good on them. I hope it goes really, really well. It's whipping around the Earth several times, to get yourself out there is sort of a crazy way to do it, but that's how it goes. You get yourself out there any way you can, and this again shows me that this kind of thing is possible, right?
Yeah.
There isn't anything new or anything that has to be invented, right? Somebody's doing it, so it's like, phew, cool, very, very cool.
Yeah, I'm gonna be right back. I forgot to get me some. I forgot to get my fuel, my water.
Oh man, yeah, that's a crisis. Yes, everyone, grab your favorite consumable of choice. I'm going to check the chat here really, really quick, see what's going on. Atta, hey, nice to see you there. Hey there, Chuck, nice to see you again. Tom, hey, nice to see you in the chat as well. So yeah, it was a good launch of the Falcon 9. It's always cool, to see those, and especially, kind of a special NATO payload like this, not just your regular old, communications satellite and all that. You've actually, got something that's actually going somewhere. So that's extremely cool. That's extremely cool. So yeah, it's actually been a pretty busy day in space. The Hayabusa 2 spacecraft that is at asteroid Ryugu apparently made a successful touchdown and gathered its sample from the asteroid. I haven't really been following that really as closely as I want to, but it looks like from what I saw, and they were actually doing a live feed of that too earlier today, but it looks like that was a successful grab as well. So that's very, very cool. And during the Falcon 9 live stream, Alan Stern, who is famous for the New Horizons spacecraft. He's sort of the head dude there. Tweeted out that there's going to be some new data from the encounter with the asteroid, or the trans-Neptunian object, which I mean is an asteroid, Ultima Thule, yeah. Hey there, curious cannabis connoisseur. Nice to see you. How did you find your way into a space channel? I don't know, but glad you're here. Glad you're here. Welcome. Yeah, this is all about astronomy, space, nerdy things like that. So welcome. Everyone is welcome here, of course. So very, very cool. As I say, sit back, grab yourself your most favorite consumable of choice, and you know, this is like a fun virtual porch, right? Or like a virtual campfire, right? And we're just sitting around chit-chatting all things astronomy, space, science, nerdy things, that kind of stuff. So absolutely. Cheers. Cheers.
And just got my faucet water. Cheers.
All right. Very, very cool. So yeah, it's been a busy day, and I'm really anxious to see this new data from New Horizons. Right? It's this asteroid Ultima Thule is turning out to be a real weirdo, right? Well, you know, and that's sort of a judgment call, right? Because I mean, we really had no idea what to expect, right? But it's sort of looking now, and I mean, this is subject to change, right? It looks like not only is this asteroid double-lobed, right, but it's also flat, really flat. So I'm hoping that the data that Alan Stern says is going to be released tomorrow is going to reveal a little bit more about this enigmatic object that is
the Ultima Thule.
Ultima Thule. It's you know, I'm glad that it's you know, sort of confounding everyone. That's what we want, right? And so, you know, everybody, you know, this is why I say on this live stream all the time, right? It's like, you know, be extremely skeptical, right? But be open-minded, right? Don't knock things out just because they don't match any kind of expectations, right? And when you hear a scientist say things like, we're absolutely sure, right? We're certain of these things, right? That to me is a huge red flag. It's like, wah, 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 you know, no. We you know, we think that we're pretty sure about things, but we get these surprises all the time, right? Ultima Thule, when we first looked at it, right, it was a double lobe thing. That was a surprise, right? It's like, what is going on here, right? Nobody knows, right? And astronomers, they have, you know, the same two answers for all these things. It's collisions and what's the other term? Accretion. Okay. Accretion is when, you know, you have this cloud of gas and dust that slowly coalesces, right? And then you have collisions, which you know, smash into one another, and those are the only two processes that most astronomers, can sort of explain things going on, right? And it's like, well, maybe there are other processes involved. I don't know. But so the double lobe thing, that was a surprise, right? And now to realize that it seems as though it's very, very flat, right? So it's not like a snowman, right? The day after the encounter, right? Or maybe a couple of days after, I started seeing, 3D prints of these, of that double-lobed rock, and it was like a snowman, right? And you saw all the cartoons, with the snowman and everything. It turns out it doesn't look like a snowman at all, right? Because it's incredibly flat. So, and that is subject to change too, right? Maybe there's something else going on there, right? That we're just not too aware of. But so hopefully tomorrow's release of some more data. I assume that there's going to be images. Maybe there's going to be other things. Yeah, we will have to see. I would absolutely love to be on that team to be able to see those images first, right? Because obviously they've seen it all already, right? And man, it must be hard, to not want to share that and talk about it, right? You have to hold back a little bit, and yeah, that has got to be hard. So cheers to those folks that can do that, because scientists, by nature, right, they want to talk, right? They want to tell everybody everything. so
Yeah.
it's got to be really, really hard, but it's going to be interesting. It is what it is. Yep.
Yeah. So I have a good question for you. How much do you know about the source code compiling and installing, getting the programs from the source code and then compiling and installing? How do you know everything about that?
Well, it depends on what you're compiling it for. Is it going to be on a Unix-based system? Is it going to be a Windows-based or a DOS-based?
Mostly in Linux.
Yeah, usually, right? Along with the source code, you will have a file that is usually named makefile with a capital M. And so that file is actually used by a Unix program called make, right? So so usually how that goes.
What do you do? What about when somebody said like Git, GitHub, QMake, or CMake? Do you have any knowledge about that? Yeah.
I've never used QMake or CMake or any of those other makes, but they are probably extremely similar to the original make, right? And so I would say, is this like some source code over on GitHub?
Yeah, I just had to update my like a little thing that makes the GQRX work with my SDR play. And I just did some updating just now and stuff.
Oh, cool. Yeah, usually over on GitHub Hub 2, there's an instruction file, right? Maybe it's called README. or something else, and there are usually instructions in there on exactly what commands to type to compile and build these programs from source. So if there aren't any instructions, what I would do is I would get a hold of the author and see if they can send you instructions, right? But as I said, yeah, I mean, if the source code require, or if this package is saying that you want to use CMake or QMake or any of those, then there probably is a make file of some sort. You need to make sure that you have the proper compiler as well. Usually the compiler that is used is either a thing called GCC or just CC, right? And that stands for C compiler. And these compilers know how to deal with C, C++, all the various flavors of C. So yeah, I would say look for some instructions on doing the build itself. And if they aren't there, I'd get a hold of the author. You actually might look in the source code itself, right at the beginning. There might be instructions there too. So yeah. Hey there, James Dugan. Hey, I'm being summoned at the door over here, so I'm going to take a quick break. I'll be back in like 10 seconds. Hold on.
Yeah. So. Cue the Jeopardy music. Oh, there it goes.
Yeah, there we go. Now my lap buddy wanted in here, so there she is. Come on over here. Say hello. Hello. She's gotten into the habit of sitting on my lap during the live streams now. So for the longest time, she pretty much as soon as I started the live stream, she would want out of here because she would be like, who is that weird guy who's talking so much, right? And like 2 seconds after the live stream would end, she'd be howling at the door saying, "Oh, he's back. He's back." But now she's decided that what she's going to do is actually sit in my lap here, chew on my fingers, chew on me. Hello. Ah. Hi, baby. No, she's
June still again. How you doing?
She's a sweetie. No, she.
Yeah, and Tim Robinson. I'm not sure if you saw his latest live stream, but he did like a quick one tonight.
I noticed that he did do one, but I did not get a chance to watch it. So she's still being like, "Oh, it's you, it's you." Yes, it's me, and there you are too. Chewing on the fingers. She's extremely gentle, though. So at least most of the time. Ow! Ow! You can make me a liar.
I still remember the one when one of your cats just jumped on your shoulder by surprise.
Yeah, they do that. Also, they're always surprising us here. So yeah. Oh, and my apologies for yesterday. I got home from the day job, and almost immediately upon getting home, I started this weird headache, right? And it just intensified and intensified and intensified, and I was like, oh man, you know, this thing has got to go away, right? It's got to go. It's got to go. And so I put it off to the last minute, but I definitely had to cancel because I mean I was like, where am I? You know, I mean, it was really intense. And I think I know why. I think I know why. It's a horrible chemical addiction, right? It's this thing called caffeine, right? And for some reason, yesterday, I decided, you know, to not have, you know, my normal couple cups of coffee, and I think that's what that was, right? Is it was the first stage of caffeine withdrawal. So that is a nasty drug. There, you know, I mean, of all the drugs, right? That is one of the most nastiest one, and it's legal and consumed by millions and millions of people everywhere, right? It's sold everywhere. But man, it is physically very addictive, very addictive. And
there's always the decaf option, or lay low with the energy drinks.
Yeah, well, you know, I mean, there are literally three. There are three things that I will drink, right? Three liquids that I will drink, okay? 95% of the time, this stuff right there, right? This stuff right there. In both forms, right? Either HOH or H2O, right? Either one is fine, right? Secondarily to that is coffee, which is mostly this, right? And third is matcha, right? Once in a while, I'll do the matcha thing, and I should probably get into that a little bit more because it's.
What's the matcha?
Matcha is a green tea that it also has a substantial amount of caffeine in it, but it also has this other chemical. I forget exactly what it's called, but what it does is it sort of it sort of gives you the caffeine high, but it doesn't make you all zippy, right? It's actually very nice, and it's extremely healthy, right? Really
so
really healthy stuff.
Curious Cannabis Commissioner says it's got to be the alien microchip malfunctioning, and he also commented about it. It says obesity, heart attacks, and diabetes. Yes, it definitely has its upside.
Yeah.
I'd like to welcome Matt Keller, also known as MDK2, a brilliant shortwave radio listener. If you follow him on YouTube, and we'd like to welcome Carolina Sky Astronomy.
Carolina Sky Astronomy. Hey, nice to see you there. Yeah, MDK2. Peace, man. Cool.
Welcome,
Glad you could come in. Yeah.
And yes, I am Bobby. For those that doesn't know, I'm usually more like a co-host and stuff. And I think, like, for sure, Matt knows me as well.
Yeah, MDK2 is always seen on Gilles, at least his shortwave live stream, if not the other ones, as as well. So yeah. Anyway, that's my excuse for yesterday. Yeah, that's just nasty stuff.
I want to like say, and speaking of like diabetes and stuff like that, I just like to say like thanks to my uncle for saying I probably might need to use his machine to check on his blood sugar, but thank God I'm at normal conditions all the time. Now, health is vastly more important, especially with the medicines that I legally take by prescription.
Ah.
And yeah, and I think one of the medicines that I take will give me diabetes.
Wow. Yeah. Diabetes.
And it's not just that. One of the medicines that my doctor told me to stop.
Well, you muted yourself there. I couldn't hear your last bit. Can't hear you. Oh, he went mute. Bobby, you went mute. That's funny. Uh-oh. Maybe it's his doctor trying to mute him. His doctor doesn't want him to talk smack about him or anything. That's funny. All right, well, cool. I'm going to continue as Bobby. Oh, there we go. There we go. All right. Yeah. So say that all over again. I missed you.
Yeah. So what is happening was like one of the medicines that I take will have diabetes. I think you got that part. And one of the medicines that my doctor told me to stop right this moment was my cholesterol, which was damaging my liver.
Nasty.
Potentially damaging my liver. It doesn't mean if it's like damaging and all that other stuff.
Yeah, yeah. Well, you know, pharmaceuticals are they're I think that they can be helpful from time to time, but I don't think that they are really helpful in the long term, right? I mean, our bodies oftentimes, you know, need help, right? But I mean, I think our bodies want to be healthy, right? And oftentimes we sort of, you know, try to help them a little too much, right? Because we think that we know, right? And we don't know, right? We don't know. Yeah, I you know, I mean, I understand, you know, the usefulness of pharmaceuticals and all drugs, right? But you know, to rely on them for health, I don't know. I think you know, you know, if your body is that imbalanced, you have to look at what you're doing. You know, and go from there, right? So yeah, and you know, I can't say that pharmaceuticals are bad, but you know,
I just like wish, even though like my church may have a bad about it, but if my state Louisiana will legalize CBDs and marijuana, I think it'll be okay. But will I take it? I don't know. But so it's more of a even if it's legalized, if I don't have to take it, I don't have to take it for sure.
Yeah, you know, I'm into choice. I'm into maximizing choice and maximizing access. So not excess, access. So yeah. You know, as I said, I think, you know, I sort of totally agree with Dr. Andrew Weil, who says, you know, that our bodies know how to be healthy, right? And sometimes they need a little bit of help, right? But for the most part, you know, our bodies know how to do stuff, and sometimes we just have to, you know, get our, you know, get ourselves out of the way. So yeah, very, very cool. So yeah, and like I said, you know, I'm into to choice, right? And to, you know, maximizing choice, and you know, things like cannabis, that's gotten a bad name for a really, really long time. And if you look into it a little bit, which I have, you'll find that it is not this you know, evil demon thing. That's incredibly wrong, really, really wrong. You know,
You know what's kind of like a bit funny is I may have a little bit of fat in me, but it doesn't look like I need to lose any weight yet. I don't know. You be the judge.
I am not going to be the judge. If you feel good, right, then you probably are, right? And that's all, you know. And I mean, how am I supposed to know what the ideal shape of a human is, right? Or weight of a human is? I don't know what that is. I don't have a clue, right? So you know, I mean, if you're feeling good, right? I mean, and that's sort of, you know, for you to decide, then you're probably doing all right, right? You know, regardless of what your shape is, or your size, or weight, or anything else, right?
Okay. I'd like to say later, Matt, but he's going to be back if he's still going to be around. But yeah, so I guess the family is more better than astronomy and radio.
Yeah, and you know, I've got to say that Carl Sagan, he was a pretty heavy cannabis consumer, and I greatly admire him. So you know,
I would always picture in mind of Carl Sagan was more like always happy, always, and like everything, every little thing was gonna be all right and stuff. So it pretty much gave me a clue about the reason why Carl Sagan is Carl Sagan, and I never knew that he was a cannabis consumer. So
yep.
Crazy.
Very, very much so. He actually wrote some articles, and he called himself Dr. X, Dr. X, if I remember right. So you can go read those articles, and yeah, they're very, very revealing. But let's get back to astronomy. You know, we're still talking about things in the constellation of Leo, right? I think it was over a week ago now that we chose to dive into the constellation of Leo just a little bit, and so I wanted to continue that.
It's kind of like a bit crazy. We just don't call it constellation of a day anymore. Let's just call it. Let's do a random something, and then
Yeah, we'll have to think about that a little bit because and you know this live stream is evolving, right? I mean, I'm always trying to think about ways to make it better, and you know, I think, especially when it comes to, like, a constellation of the day, right? I mean, I realized early on, right, that there is no way, there's no way that I can or should um, try to cover everything that I would like to cover when it comes to a constellation. There's too much, right? There's way too much. So maybe it should be, like constellation of the week or constellation of the month, right? Maybe constellation of the month. Um, that might be a good thing. There are 88 constellations, so that'll last us 88 months, right? I have no problem with that.
Yeah,
So
that'll be great that way. I can understand like a galaxy update, like an MTC or a Messier, but
yeah,
constellation's
yeah.
gonna take a good while.
I agree. I agree. Okay, so let's think about that. But yeah, let's contemplate doing like a constellation of the month, right? And see how that goes. So yeah, one of the interesting stars in the constellation of Leo is the star called Wolf 359. And Wolf 359 has the distinct honor of being the third closest star to us, right? If you don't count our sun, right? So besides the sun, the next closest star is Proxima Centauri, right? And number 2 is Alpha Centauri, right? And number 3 is Wolf 359. Now, this is a very, very, very faint red dwarf star, extremely low luminosity. So intrinsically, right, it's very, very, very faint. So even though, at least according to Burnham's, and we'll sort of check this with Simbad and all that too, but at least
What
according
is
to
the theory that when it comes to star formation, there's always got to be like planets moving around? What is your give or take on it?
I we 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 think that we know how planets form, right? And I don't know if that's right or not. Not quite sure, because we only have sort of one example, and even that one example is sort of, I mean, it's all based on models, right? Everything is based on models. We haven't been observing things long enough to really have a good idea about what's been going on, right? So, but we think that we have a lot of confidence in this idea, that a star forms out of a large cloud of gas and dust, right? But then there's all this residual stuff, right? Once the star forms. And out of that residual stuff, planets form, right? That's sort of the going theory. Now, whether that's right or wrong, I don't know. I don't know. But if you go with that, right, then it seems to me that it's sort of logical, right? Sort of deductive reasoning says that most stars are going to form pretty much of the same way, and so there's also going to be lots of residual stuff around them, which means that I would think that most stars, and even multiple stars and clusters and all of that, are going to have planets, right? Because there's no reason to, at least the observations are sort of indicating, right, that we see very, very, very large objects, right, that are, you know, hundreds, thousands of times larger than our sun, right, all the way down to little pieces of dust, right, and everything in between, right, everything in between. So to think that planets, you know, don't form around stars is sort of illogical, right? So yeah, I think that there are probably planets everywhere, right? They're just hard to see, right? Because they're really, really small. They don't shine like stars, right? So we have to try to look at their reflected light from their star, you know, that they're going around. And they're very, very, very likely to be these rogue planets as well, that are planets that are just flying around all over the place, not associated with any stars, right? And there's actually a theory that says, you know, that several of the planets of our solar system, including the Earth, was actually part of a rogue planet system, right? That was captured by our sun. So you know, there's lots of ideas out there, and you know, is somebody right or wrong? I don't know. Don't have a clue.
I think I decoded something one time on shortwave radiogram. I don't know what episode it was, but they were saying about the way how our early solar system formed, and there were some planets colliding on other planets and stuff. So I guess let's.
Yeah, cool. Well, yeah, I think I mean, you know, sort of stay tuned. I mean, if you think that you're going to be around in the next 10 or 20 or 30 years or so, I think we're in for a lot of surprises, because for the first time in that time period, we're going to be able to not only be able to directly image planets around other stars, but actually look at their spectra and see what they're made of. Right.
Yeah, that's something what the presiding officer of the Church Jesus Christ of Latter-day Saints would say: get some rest, eat your vitamin pills. It's going to be good.
It's going to be interesting, right? And yeah, I mean, it's a great time to be around. Anyway, so Wolf 359 is currently in the constellation of Leo. It's extremely faint, right? It's at least according to Burnham's, its visual magnitude is 13.66. So it's really, really, really faint. You know, even being so close, and again, at least according to Burnham's, it's 7.75 light years from us. So yeah, that is really, really, really close. So I think what I want to do is go over to Simbad and see what Simbad has to say about Wolf 359. So let's
you know, it's kind of a bit funny whenever you said that about Wikipedia not being updated or having some errors and stuff like that. When I was at high school, when in English classes, when you got to do like resource papers, you're not supposed to use Wikipedia at all. Mm-hmm. You're supposed to use the reference books from the library in the school's database system.
Yeah. Okay. Well, you know, Wikipedia is, I consider that to be a nice jumping off point. But yeah, I don't necessarily consider it a reliable source. But, you know, we've also noticed that Sinbad isn't necessarily reliable either, right? And Sinbad is you know, one of the most used, most relied upon astronomical databases, and you know, it's prone to error as well. So I mean, you know, in doing any kind of research, right? You try really hard to not rely on one source, right? Look at your options, right? See what's out there, and you know, get a feeling, you know, for things that way. Anyway, so all right, here we go. So, wow. Okay. Well, the first thing that I notice about Wolf 359 is its proper motion, right? Now, these numbers, of course, are in milliarc seconds per year, right? So it is moving towards the west in right ascension at about 3.8 arc seconds per year, right? I'm just dividing this by 1,000. And it's moving south by 2.7 arc seconds per year. So, wow, that is really moving fast, right? So, you know, the only way that we'd be able to see it moving that fast is if it's really close, right? So it apparently is. So here's all the magnitudes, right? So U, B, V, R, I, these are all different wavelengths of light, right? So U, B, V, and R are sort of in the visible wavelengths. So are G and R down here. I, J, H, and K are more towards the infrared, right? So as you can see, it's actually very bright towards the infrared, right? Which is indicative of a very red star, right? I mean, if it's a red star, then it is going to be emitting a lot of red light and not a lot of blue light, right? So it's very faint in the blue, right? And very bright in the infrared. Unfortunately, we can't, you know, see with our own eyes in the infrared. So, of course, you know, we rely on different kinds of instrumentation to give us a hand with that. But yeah, it's amazingly bright towards the infrared. Wow, that's you know, that's what, 6.5, what, no, 7.5 magnitudes, right? And every magnitude is a factor of 2.5. So let me see, I'm going to grab my handy dandy calculator here, and I'm going to say 2.5 exponent 7.5. So that's a factor of 965, right? So Wolf 359 is almost 1,000 times brighter in the infrared than it is in the visible. Wow, that is pretty amazing. That's a very red red star. Yeah, very red. All right, so here's sort of the normal list of names. Obviously, it's got a bunch of different names, lots of different names here. Sometimes multiple names in the same catalog. I don't know how that works. Maybe it's a different versions of the catalog. Not quite sure. Let's see, anything outstanding here? I don't really see anything outstanding here. It's probably very well studied. Yes, oh yeah. So 601 references. That's quite significant. some distance measurements, some proper motion measurements, some velocity measurements. Let's see what we got here. So this is saying 2 parsecs. So a parsec is 3.26 light years. So 3.26 times 2 is 6.52. So that's from 2014. So Burnham said it was 7.75 light years, which would put it at almost 2.4 parsecs. So I would sort of trust this more updated distance measurement a little bit more, I guess. Sort of.
Welcome back, Matt.
Hey there, MDK2. You're back. So yeah, I'm kind of confused by these radial velocity measurements, especially this last one. I'm not quite sure what's going on there. That, all of these other ones are sort of the same, kind of, sort of. This one's way out there, so I'm not quite sure what's going on. What's their official radial velocity? They say 19.321. So, of course, radial velocity is just how fast this star is moving radially, either towards us or away from us. And in this case, in a radial sense, it's moving away from us at, I guess, 19.321 kilometers per second. But I don't see this reference here. So, or maybe that's it. AJ 147, is that it? AJ 147. No, this is an AppJ thing. So, yeah, I'm not quite sure why see, that's why I say, even Stimbad is a little inconsistent, right? They don't have the same measurements here as they do up here. So that's why you've got to keep your eyes peeled for those kinds of things. Anyway, proper motions look like they're pretty consistent, right? I always like to sort of look at, if the proper motions have changed over the years, right? And it's sort of all over the place, so it's kind of hard to tell, right? I'm kind of interested in knowing, if the motions of these stars are, accelerating or decelerating. Don't know. Very, very cool, though, in terms of temperature. Somewhere around 2,800 degrees Kelvin, which is about 1/2 the temperature of our sun. Right, so it's relatively speaking, it's a cool star, definitely a cool star, and it looks like pretty much in agreement in terms of the spectral type, right? M is a very, very red star, and then I think it goes from M1 to M9 here. So this looks like it's being classified as about what M6. And let's see, sort of officially up here, M6. Yeah. Okay. Cool. What else we got here? Some observation logs. Let's not get into that. I think there's probably... Uh-oh, we got a doggy alarm. So, wow, this isn't being really properly marked here. Let's see if it even shows up.
That's kind of like a bit weird.
Yeah, it's a little weird. They're probably combining several photographs to get these, sort of color pictures. So things don't seem to quite be aligning. And part of the reason why, possibly, is because these images were taken at different epochs on different dates. And this thing is moving, right? It's moving fast. So, I mean, if you don't...
Arrow away for you, deep sky dude.
Oh, is Deep Sky Dude here? Cool.
Yeah.
Excellent. Thanks for stopping in. We're looking at Wolf 359, the third closest star to us in the constellation of Leo. It just so happens to be in the constellation of the, well, the constellation that we're currently examining a little more closely. I think I'm going to start calling it the constellation of the month. I think that's probably the best bet. So yeah, that's probably what is going on here. Why it looks so weird is because these images were probably taken at different times, and this thing is trucking, right? I mean, it's moving. Well, what a total? We can actually do the math here really quick. Grab my
trucking like an 18-wheeler or what?
It is trucking like fast, major fast, right? 3842 squared plus 2725 squared, and then take the square root of that. Whoop, I did that wrong. Let's try it again. 3842 squared plus 2725 squared equals that square root. So yeah, it's moving almost 5 arc seconds per year, right? So that is screaming, right? That is moving fast. That is moving really fast. So that, as I said, that probably explains why this looks a little weird, right? And it's not quite in the right place because it's moving. It's moving fast. Now, at least according to Simbad, it should be moving this way and this way, right? So I'm not quite sure why it's up here, but yeah, I don't know. Might want to think about that a little bit, but I'm not going to worry about it too much at this point. All right, so let's dive into the references here and just see. Let's look at the sort of the latest on it and maybe the earliest work on it. In fact, what we can do, we can actually go over to archive.org and we can actually search for Wolf 359 in the top and see how that comes up. Oh, that's a lie. I put it in quotes. That has to be. What? No, that doesn't make any sense. Let's try all fields. New parallax measurement for the coldest known brown dwarf, and that's it. That's it, huh? That seems a little weird.
You freaking suck, Archive.
Yeah, that doesn't make much sense. I think. I wonder if it's how I'm searching for it. I mean, because this is sort of the common name, right? As we know, it has a cajillion other names. I wonder if it would fall under any of these other names. Of course, I'm not gonna sit here and
crazy that Gaia didn't study it.
Well, Gaia probably does have it mapped for sure. But yeah, it doesn't have a designation here yet, right? And that's why I say, you know, I mean, Simbad is a great repository of information, but it doesn't have everything, right? And sometimes it can be wrong. So, all right, well, we'll just do it this way then. Let's see. So radii of 88 M subdwarfs and updated radius relations for low metallicity M dwarf stars. Let's see if Wolf 359 is in one of these. Now, this is a really, really recent paper in the Astronomical Journal, all right? 2019. That's pretty cool. So let's see. Let's just dive right into it here.
And they like just released it or something, probably around February 1st or something, huh?
Yeah, we'll be able to find out here. Publication date February 2019. So pretty recent, I would say. Over on the archive. Let's see if it's actually listed, though. That's the real question here. I'll zoom in a little bit here. We compile a sample of 88 stars that span spectral classes K7 to M6 and include stars with metallicity classes from solar metallicity white dwarfs to the lowest metallicity ultra subdwarfs. Okay. So let's just search for Wolf. Oh, not Wolf. Wolf. No, that's not doing it. 359.
I think what you do is let it take its time to like index the paper, and you can go from there.
Yeah. Well,
I know you don't have to. I don't know why you didn't like let it go and stuff.
Oh, well, it usually pops up really, really quick. But see how these are named LHS numbers? So that's what we need to look for over here on the list of names is an LHS number. There it is, LHS 36. Oh, LHS 36. LHS 36. Are we seeing LHS 36 anywhere? I'm not. Does it have another LHS number? It's an LHS there. Nope, that's it. Yeah, it drives me crazy. Sometimes.
Search.
Yeah. LHS 36. 360. Oh, that's it.
Yeah. Crazy.
Crazy. Yeah, see, that's why, you know, sometimes I'm not quite sure why.
Why is it there when it's really not?
Why? Yeah, I mean, this is a reference that is somehow supposed to be related to this object, right? Da 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 da. And we go to the paper, and there's no mention of it. So, I mean, I'll do a Wolf again, right? Nothing. 359, nothing. So, frustrating. Let's see if there are any more tables, right? Maybe there are other names that they used. Ooh, here's some spectra. Those are always cool. Sort of visible light spectra going into the infrared, right? So actually going close to the ultraviolet, right? Our eyes can basically basically see between about 4,000 and 8,000 angstroms, somewhere in here, right? So these are slightly dipping into the ultraviolet and going quite a ways over into the infrared. So that's pretty cool.
May have like a WISE or a, let's see, I know you already did LS, there's a LS or J.
Yeah. And there's a WISE.
And I think that's about it.
There's a WISE A. 0707. That's not that. Oh, those aren't the right. Yeah, there's a WISE A. Did you say there was an LA or an LSRJ? Let's see. LSRJ. I'm not seeing any LSRJs here. Right. But pretty, you know, these cooler stars have very, very complicated spectra, as you can see, right? There's a lot going on here, right? There's a lot of similarities, right? You've got this.
I have to say good night, Atalanta.
Yep. Take care, Atta. Thanks for coming in. Nice to see you in the chat all the time. So yeah, you know, it looks like there are, you know, some very similar spectral features here, but as you can see, they're all slightly different, right? This absorption line here, right, is really deep compared, you know, to this one, say, right? So there's something else slightly going on there, right? There's even, you know, in this case, right, it looks like there's some emission lines here, right, where there aren't any. Well, you know, there's a little one here, but, you know, there aren't any anywhere else. And it's like, what's going on? But let's see if there's any more tables of names. Okay, so here they're examining a few other. Let's see, GL393, is that one of them? GJ, GL. No, I don't see any GLs. All right. Yeah, why exactly this is here? Who knows? There's more LHS numbers. I guess I didn't try that. LHS 36. I didn't make it all one. There's that one. 364. 360, 364. No. Nope, ain't happening. There's some GLs here, but yeah. Yeah, don't know why that's mentioned at all. So let's move on a little bit. I know it's getting a little bit late, so I don't want to go on too long here. See, now, you know, why is Oumuamua referenced here, right? What's
even that?
Oumuamua was that interstellar object that flew through a few months ago. It was supposed to be really elongated. I think you asked about that, actually. But you know, why is this referenced here with reference to Wolf 359? I'm really curious. 2,000 stars and found just a handful of candidates. Maybe that's why. Curious, very curious. They're trying to find the origin of that object, where'd it come from, right? So maybe they postulated that maybe it came from Wolf 359. I don't know. I'm postulating about their postulating. So Wolf 28. Oh, there it is. So let's see. What is this? 109 individual objects to fulfill the following conditions. An object must approach Oumuamua closer than 3.5 parsecs before leaving the heliocentric sphere of a 300 parsec radius. Okay, so I guess what they're saying is that Wolf 359 was a candidate to possibly be where this object came from, right? Lots of candidates, though, right? Lots of candidates.
Just make you curious about who's the winner of chicken dinner.
Yeah, yeah. Well, it looks like they are investigating this, and I'm not going to get into this much. That's kind of interesting, though. I mean, you know, this is sort of a mystery object, right? I mean, it came in, it went out, and it's just, you know, it's a weird one, and pretty certain that there are actually lots of these, but you have to sort of be at the right place at the right time in order to see it, right? Because they're going to be moving in very unusual ways, and they're probably going to be really, really faint. So, all right, well, let's see what else it has to say about Wolf 359, if anything. So it just did that. Yeah, okay, so it's just listing, you know, some other wolf stars. So yeah, Wolf 359 was apparently a candidate. I don't know if they came to any conclusions or not. Looks like they've got some interesting graphs here. Okay, these are all in the appendices. Let's back up here and go to the text. Supplementary material, all the references, discussion and conclusions. Ah, look at that. No obvious parent star has been identified. Wah, wah. So, yeah.
Encounter with HIP 3. Kind of crazy about that object that is floated around throughout the galaxy.
Yeah, yeah. Nobody knows. Nobody knows, and you know, we probably never will. So, but that's all right. I like those kinds of mysteries. No problem. All right, let's look really, really quick here because I don't want to take up too much time. Let's go back to the earliest paper and see what that's all about. Oh, I went too far here. General Catalog of Stellar Radial Velocities, 1953. So it doesn't go back very far, right? But then they've got proper motions, right? So yeah, this is probably one of the first times, you know, they realize that it's like, whoa, that thing is moving. The infrared spectrum of the cool dwarf Wolf 359 from 1969. Should we take a look at that one really quick? Let's do it. So by then, I'm sure, you know, we knew that it was really, really close and kind of a awesome little star, right? At that time, I don't think that we knew about Proxima Centauri, right? So Barnard star is pretty close too, but I don't think it's quite as close as Wolf 359. So yeah, that's pretty cool though. So let's see. So yeah, you know, once we discovered Proxima Centauri, then Barnard star got tossed off of the top 3 list. So titanium oxide in the spectrum, that's pretty cool. Let's see if they actually have a spectrum here. Neutral potassium, sodium, and an unidentified feature at 9,900 angstroms. That's pretty cool. I like that. Oh, there's no picture. There's no spectrum. That's not very nice.
Yeah.
But they took its temperature, and I think that's about right. Seems to coincide with modern day stuff. But yeah, they found, wow, look at that. They found dihydrogen monoxide. Wow, that's awesome. I like it. I'll drink to that. Awesome stuff. Also found, I think that's, is that hydrogen sulfide? I don't know my chemistry too well. That's, of course, carbon dioxide. Cool. Yeah, so they don't show a spectrum, but they, you know, they have identified certain absorption features, and you know, talk about it here. So that's 1969. So that's 49 years ago. So that's not too bad. That's not too bad. All right. Well, cool. Yeah, Wolf 359, the 3rd closest star to us in the constellation Leo. Very cool.
Now, just out of curiosity, since Barnard star was mentioned, were there any artist conceptions of the planet that was orbiting Barnard's?
Do we have a confirmed planet around Barnard star?
Not only just confirmed, but an artist's conception.
Oh, I don't know. Probably easy enough, you know, to do a search on that kind of stuff. But yeah, you know, we're just now getting into a phase in astronomy where we can actually directly image features on stars, right? I mean, we've sort of been able to do that for a while, but you know, you have to use adaptive optics or some kind of, you know, fancy stuff to do that, and that's relatively modern, right? So
I hope the next stop when it comes to astronomy and discovery is actually doing some manned discoveries, not only through Mars but beyond the solar system and scope.
Yeah, I think we're a little ways away from that, but I think in terms of, you know, definitely the moon, definitely asteroids, right? I don't think that there's any reason why we shouldn't be going there. I mean, we sort of need a good reason, though, right? And a very, very good reason, right, is a commercial reason, and you know, to actually develop a presence in space. There is, I mean, really an unlimited amount of resources out there, right? So, I mean, we have to start learning how to extract things from, you know, the moon and asteroids, you know, to build stuff, right? We definitely don't need to be launching everything from Earth, right? But yeah, you know, I think in some cases, a human presence there would make it better. But I think, stuff like tourism, right? I mean, I want that 7-day cruise to the moon and back, right? I mean, I want to do that, right? I think that'd be great. And I think that, developing a business model for that, I think that would be an incredibly viable business if you can get your costs down, right? Elon Musk says that he's aiming for $100 a pound, right? $100 a pound, right? Which makes a cruise to the moon and back affordable, right? I mean, it's still expensive, right? Don't get me wrong, right? But for $20,000 or $25,000, right? You can have a 7-day cruise to the moon. That's not bad, right? I mean, it would be a once in a lifetime thing. That's enough, right? But sort of the Apollo 8 style, right? And for the price of a car, right? That makes it reachable by a large segment of the population. So I think that's a great business model, and I think companies like Blue Origin.
Do we think we will have some manned research and exploration before there was ever a residential and tourism or something like that?
Yeah, I mean, we're going to have to set up some kind of a human presence wherever we want humans to go, right? Because there have to be things at these destinations, right? And so yeah, I think all that's going to happen. We just have to keep working on lowering the cost of this stuff, and make it more reachable by more people. But and not everybody's going to be able to afford it, right? But a lot of people will, and so yeah, I think it's a doable thing. But I'm running really, really late, even though we started a little bit late. So I'm going to get out of here for now. So I'm really, really glad that you all came in, hung out this whole time. So really, really glad everybody's here. And plan is I'm going to do this tomorrow. So I'll definitely have to at least have a couple sips of coffee. I think I'll be good to go. So, all right, everybody, well, take care. Peace, cheers, and all that. Have a great evening, a great day. Make sure to subscribe if you haven't already. Make sure to hit the thumbs up if you so desire. Make some comments. I like to see comments, criticisms, right? I mean, I want this live stream to get better and better and better and better. I don't know what that means, but maybe you have some ideas, right? But I mean, that is sort of the goal right now, is just to try to get better each and every day. And do I accomplish that? I don't know. I think it's a lot like most things. You sort of improve, and then there's a plateau, and then you improve, and there's a plateau. I think that's how those kinds of things go. So hopefully, over time, things will get better and better and better. Who knows? So, like I always say, as long as you're having fun, that's what counts. And I am definitely having fun. Definitely. So, all right, I'm going to get out of here. Cheers, peace. I will see you on the spin. See you later. Bye.